Hello and welcome. So it's time to solve problems from what we have learned so far. So looking at this question, we are told that this PN is perpendicular to QR. So it means that we have a right angle triangle here. So there is right angle here, right? And then we are told to find the value of tan x. This is our angle x. So we are looking for tan x, and tan x, of course, tan from our Secant to tan is or tan x is going to be opposite upon adjacent, right? That's from Secant to opposite upon adjacent. So our opposite is this side, and our adjacent is this side, and the side that we have to be adjacent in this case is going to be from this end to r, nr. But we are not given the value of nr, we are given the value of this total value, which is length, which is from here to here, which is actually 9 cm. So how do we find? We don't have the value of this nr, which is what we need. We don't have the value from here to here, right? This distance, we don't know the value. So we can call it y, right? Okay, so how do we find the value of y? What we'll do is to first of all find the value of here. Because in this particular triangle, there are two right angle triangles here. In this one, we know the value of this side and this side. So we can easily find the third side, right? We can easily find this third side. Now, if we find this side, we'll be able to subtract it from 9 and it will give us the value of y, right? So how do we find the value of this side? You're supposed to be familiar with the Pythagoras triple. Pythagoras triple, we have a right angle triangle where the hypotenuse is 5, one other side is 3, so the remaining side is going to be 4 cm. We have to, there's no need to solve it. So we know that this missing side is going to be 4 cm. So we'll have that. If we call this missing side, if we call it z, so we'll have that z is 4 cm from Pythagoras triple. So if z is 4 cm, then we'll now have that z plus y is going to be 9 cm. That's what we are given, right? Given. So y is going to be 9 minus 4. So y is 5 cm. So the length of this side is 5 cm, right? And then how we'll now find, we are looking for tan, which is opposite upon adjacent. Our opposite is 3. So tan x is opposite, which is 3 cm, upon adjacent is y, which is 5 cm. So 3 upon 5. So our answer is option B. You see how simple it is. So that's how simple it is. We'll solve another problem. So for the second example, let's see. We have this triangle and we are looking for, we are told that this angle QPR, okay, here should be, right? QPR is 90 degrees, and then PSR, that's PSR, is another 90 degrees, and we have to find the length of QS. QS is this from here to here. So how do we find that? First of all, we'll go ahead and find. We'll have to find the value of this side, because this is the common side to this triangle and this one. So we have two major triangles that we are considering here, this and this. So the common side to the two triangles is this particular line. So we'll find the length of this line, and then we'll use it to find the length of this line. So how do we do that? What we'll do is, from our Secant again, we have that this is the hypotenuse and here is the opposite. So the relationship between opposite and hypotenuse is sine, right? So, but we don't know the value of this angle here. We don't know the value of this angle. How do we find it? Here is 25, and then this is another right angle triangle. If here is 25 and here is 90, as we have seen, here is 90, here is 25, and then there is another 90 here, meaning that what will be left here is 90 plus 25, all this minus 180 minus the 90 plus 25, it will give us the value of the angle here. And this angle is going to be 90 minus 25, which will give us 65 degrees. So this angle is 65 degrees. And then since this is 90 degrees, you subtract 65 from 90, it means that here is another 25 degrees. So here is another 25, leaving this angle to be 65 again, because you have to add this and this to give you 90, so that the sum of angles here will be 180. I hope you understand how we were able to find the value of this angle to be 65. It was not given, we are the ones that found it, right? So since we find that this angle is 65, we will now use it. So sine, we now have that sine theta is equal to opposite upon hypotenuse, right? Then our theta in this case is 65, so we have sine 65 is going to be, our opposite is the unknown side, which we can call x actually. So x upon hypotenuse is the longest side, which is 5. So to find the value of x, we say that x is equal to 5 sine 65. That's the value of this side x. Then again, we'll now look for the side that we are asked to find, this remaining side. So how do we find the value of this side? We still use this triangle. In this triangle, we have here is the opposite. For this triangle, here is opposite and here is adjacent. So they'll be related by tan. So opposite and adjacent is connected by tan theta. And that's, so if here is x, we can equally call here y. So we say that sine tan theta is opposite upon adjacent. So tan, our theta in this case is 25, is opposite is x upon our adjacent is the side we are looking for y. So y, to make y a subject, we have that y is equal to, just cross multiply and you have that y is equal to x upon tan 25. But that's when you cross multiply and divide by tan 25, you get that y is equal to x upon tan 25. And we know the value of x. X is 5 sine 65. So we have that y is equal to x, which is 5 sine 65 all upon tan 25, which is 5 sine 65 times 1 upon tan 25. And 1 upon tan 25 is called cot. That is inverse of tan is cot. So y is equal to 5 sine 65 times cot 65. So y is equal to 5 sine 65 cot 25. So our answer is B. And here is the third example. This is a question where we have that here is 90, this angle is 90, and we are told to find, we are given that here is 45. So we are told to find the value of PS. PS is from here to here, which I can call y, and then we go ahead and solve. So since we are looking for this side, we need to know one of the sides of this triangle. But then the way to do that is we'll have to find the value of this side, which is a side that is common to both triangles. So we'll find the value of this side that I call x, and from here I'll be able to find this one. So how do we find this x? This side is opposite to this angle 60, and then this is the hypotenuse. So using our Secant tool, we have that the relationship between opposite and hypotenuse is sine theta. So we have that sine theta is opposite upon hypotenuse. And then our theta is 60 degrees, so we have sine 60 is equal to, the opposite is x and the hypotenuse is 8. So when we cross multiply, I have that x is equal to 8 sine 60. For sine 60 is root 3 over 2, so we have that x is equal to 8 root 3 upon 2, which you cancel to be 4 root 3. So that's the value of this side. And looking at this triangle, it is, here is 45, here is 90, so it means that here is 45, which means that this triangle is a right angle isosceles triangle. So these two sides will be equal. So this x is the same as here, so here will equally be x. So this is x, this is x. We are looking for the longest side, which is hypotenuse. So we can use Pythagoras theorem, and from Pythagoras theorem we can say that y squared is equal to x squared plus x squared. Because the sides are equal, we are calling them x, each of them. So y squared is equal to, x is 4 root 3 squared plus 4 root 3 squared. And this is going to be, y is going to be, when you square this, you have 16 times 3 plus 16 times 3. That's 4 squared is 16, root 3 squared is 3. The same thing happens here. So y squared is equal to 16 times 3 is 48 plus 48. So y squared is equal to 48 plus 48 is going to be 96. So y is square root of 96. Square root of 96 is written as square root of 16 times 6. And if you bring 16 outside, it's going to give us 4 root 6. Because square root of 16 is 4. So we're having 4 root 6. 4 root 6, our answer is B. So, question number 4. We are looking for x. We have to find x in the diagram. And we have that this QR is 3. Then here is unknown. And then this angle is BSR is 90. So this is right angle. Okay, so we are looking for this x. Okay, how we do that? This first triangle QPS is right angled, and the other triangle RPS is equally right angled, and the common side is side x. So to find this side x, let's first of all state that we know that this unknown side, if I call this unknown side y, if I call it y, x and y will be equal. Do you know why? Because this triangle is right angled, and then one of the angles is 45, which means that the remaining angle, which is the angle here, is going to be 45 also to make 180. So this angle is going to be 45. And if this side is 45, this angle is 45, and this angle is 45, it makes this angle to be an isosceles triangle. So this side and this side will be equal. So that's the logic. So because of that, we will boldly say that x is equal to y. So then for the last triangle, using our Secant tool, we are having that the relationship between this opposite and the adjacent is tan theta, opposite over adjacent. So we will say that tan theta is equal to opposite over adjacent. So for that last triangle, our tan theta is 30, is opposite, which is x, upon adjacent. The adjacent in this case is 3 plus y. So 3 plus y. But tan 30 has the value of root 3 upon 3. Is equal to x upon 3 plus y. So when you cross multiply, we'll have that 3x is equal to 3 into 3 plus y. So 3x is equal to 3 root 3 plus y root 3. But then we say that x and y are equal. So we can remove this y here and replace it with x. So that we will have one unknown in this equation. So we will write 3x is equal to 3 root 3 plus x root 3. Instead of y root 3, we now call it x root 3 because x and y are equal. So collecting like terms, we have 3x minus x root 3 is equal to 3 root 3. So the common term here is x. And when you factorize, you have x into 3 minus root 3 is equal to 3 root 3, right? And then we divide through by the coefficient, which is 3 minus root 3 over 3 minus root 3. So, and that will give us that x is equal to 3 root 3 upon x is equal to 3 root 3 upon 3 minus root 3. Then, one thing we can do is to rationalize this expression. So, to complete the solution, we will need to rationalize the value of x. So, we have x is equal to 3 root 3 upon 3 minus root 3. Then to rationalize, we multiply by the conjugate, and that conjugate is 3 plus root 3 all over 3 plus root 3. So that's the conjugate. If you treated sort, you understand the rationalization process. So we have x is equal to, use this to multiply, this is 3 root 3 into 3 plus root 3 all upon 3 minus root 3 into 3 plus root 3. So when you multiply this, 3 root 3 times 3 is going to give you 9 root 3. 3 root 3 times root 3 will give you 3 times 3, because root 3 times root 3 is 3. So over, when you multiply this guy, this is difference of two squares. So it is going to be 3 squared minus root 3 squared. So this will now give you 9 root 3 plus 9 all upon 9 minus 3. So factorizing the numerator, we have 9 into root 3 plus 1 all upon, here we have 9 minus 3 is 6. When 3 goes here, we have 3. 3 goes here, we have 2. So we have 3 root 3, 3 into root 3 plus 1 all upon 2. So our answer, 3 into root 3 plus 1 upon 2. That's option D. Question number 5. We have we are given that XC is 10 cm, and we are looking for RY. RY, that's from here to here. From here to here. Now we have to recognize one fact. This is right angle triangle. That's XYZ. It's right angle triangle. Assuming that here is 90. So this is right angle triangle. Now, if it is right angle, and then you see this angle here, 30 plus 15, shows that the total angle here is actually 45 degrees. So if that is 45, it means that here will be equally 45. So because here is 90 already, so if here is 45, here is going to be 45. So if those two places are 45, it means that this 10 cm, that YZ is going to be 10 cm too. So XZ and the YZ will be equal, because if here is 45 and here is 45, it's an isosceles triangle. So expect YZ to be equal to XZ. So means that here is 10 cm. So the only issue we have is to find RZ. Once we find RZ, we subtract it from 10, which is, so we can say that YZ is 10 cm. So now, once we find RZ, we subtract it from from 10, it will give us YR or RY. Okay, so how do you now find it? Looking at the smaller triangle, that is XRZ. The opposite is RZ and the adjacent is 10. So we are now having that from Secant 2 again. We have that tan theta is opposite upon adjacent. So tan our theta in that case is 30 is opposite, which is RZ upon the adjacent is 30. So tan 30 is root 3 upon 3 is RZ upon 10. Sorry, upon 10. So when you cross multiply, we have that 3 RZ is equal to 10 root 3. Divide both sides by 3 upon 3. You now have that RZ is equal to 10 root 3 upon 3. That's the length of RZ. So, but then what we are looking for is YR or RY. So we say RY is equal to 10 minus RZ. So RY is equal to 10 minus 10 root 3 upon 3. So the LCM to that is going to be 3. So, and when 3 is the LCM, this is going to be 30 minus 10 root 3. So RY is this, which is, we can factor out the common term, which is 10 into 3 minus root 3 all upon 3. So, which we can bring out the 10, and we'll have that this is 10 into what we have here is 3 upon 3 minus root 3 upon 3, which is sent as 10 into 3 upon 3 is 1 minus root 3 upon 3. So what we have is 10 into 1 minus root 3 upon 3. Now, looking at our options, if you rationalize this guy, you get this value. If you rationalize 1 upon root 3, you get root 3 upon 3. So our answer is option B. Now we have that sine theta, this sine theta is root 3 upon 2, and theta is less than 90. Then we have to calculate this relationship. Okay, now how do we do that? We say, since this is a known value, we'll just take the sine inverse to find the value of theta. So this sine theta is root 3 upon 2, then theta is sine inverse of root 3 upon 2. And sine inverse of root 3 upon 2, that is the sine of the angle that will give you root 3 upon 2, is actually 60 degrees. Because when we are deriving special angles, you know that root 3 upon 2, sine 60 is root 3 upon 2. So theta, in this case, is 60 degrees. So once we have found the value of our theta, we'll now go ahead and put it here. I have that tan 90 minus theta upon cos 2 theta is going to be tan 90 minus 60 upon cos 2 times 60. And then when you do that, you have that this is going to be tan 90 minus 60 is 30 over cos 2 times 60 is 120. So this is going to be tan 30, which is 1 upon root 3 or root 3 upon 3 over cos 120. Cos 120 is the same thing as cos what? 60. So cos 120 is cos negative, but it's going to have a negative sign. Cos 120 is negative cos 180 minus 120. That's how we find it. So which is 1 upon minus, cos is negative in the second quadrant, so that's why we are using this. We are putting this negative sign. So cos 180 minus 120 is 60. So this is going to be 1 upon root 3 actually. So this is going to be 1 upon root 3 over cos 60 is half. So we are going to have minus 1 over 2. So this is now 1 over root 3 times minus 2 upon 1. So this is minus 2 upon root 3. Minus 2 upon root 3. So our answer is option C. Example 7, we have that tan theta is 3 upon 4 and we have to find the value of sin theta plus cos theta. So how do we do that? We say tan theta from SOCA to tan theta is opposite upon adjacent. So in this case we are given that it is equal to 3 upon 4. So it means that our opposite is equivalent to 3 if our adjacent is equivalent to 4, right? So if we draw a right-angled triangle with here as theta, our opposite here is 3, then our adjacent is 4. When you remember Pythagoras treble, to find the hypotenuse is not an issue. The hypotenuse is already 5 according to Pythagoras treble. So there is no need to start solving for this. But Pythagoras theorem will give you this. So this is, we already know that hypotenuse is 5. So that's what we understand from this. So we'll now go ahead and see that sin theta is going to be opposite upon hypotenuse. Opposite upon hypotenuse, which is our opposite in this case is 3, our hypotenuse is 5. Also, cos theta is adjacent over hypotenuse. Adjacent over hypotenuse. So cos theta, our adjacent in this case is 4 and hypotenuse is 5. So we are told to find sin theta plus cos theta. So we now say that sin theta plus cos theta is going to be, sin theta is 3 upon 4, 3 upon 5, plus cos theta is 4 upon 5. And since LCM is the same, or the denominator is the same, we are going to have 3 plus 4 all upon 5, right? And 3 plus 4 is 7 upon 5. How many times do we have the 7? That is going to be one whole number, 2 upon 5. So our answer is option C. That's the answer. Question 8. We have that 4 sin square x minus 3 is 0. So we are looking for x. So let's try to make x the subject. First, we move this guy. I'll have that 4 sine squared x is 3. Divide both sides by 4, and we are having that sine squared x is 3 upon 4. Then sine squared x is what we have here. So let's find sine x by taking the root of both sides. When we take the root of both sides, we'll now have that sine x is going to be root 3 upon root 4. So sine x is root 3 upon square root of 4 is 2. So sine x is root 3 upon 2. So x is sine inverse of root 3 upon 2. So which angle will the sine give us root 3 upon 2? So the sine inverse of root 3 upon 2 is 60 degrees, as we know from the table. So our answer is option C. That's the correct answer. So here is to question number 12. We have sec squared theta plus tan squared theta. Remember that sec squared theta is inverse of cos. So we write this as 1 upon cos squared theta. That's representing sec squared theta plus. Remember that tan theta is sine theta over cos theta. So this is sine squared theta upon cos squared theta. All this will equal to 3. LCM of this, their common term is cos squared theta, right? And then this device, we have 1 plus this device is sine squared theta is equal to 3. But recall again that when we on the trig ratios, we said that cos squared theta plus sine squared theta is 1. So from here, if I make sine squared theta the subject, I have that sine squared theta is 1 minus cos squared theta. So borrowing this value of sine squared theta, I can replace sine squared theta in this equation, and then I'll have 1 plus, instead of sine squared theta, I'll now write the value of sine squared theta, which is 1 minus cos squared theta. All this upon cos squared theta is equal to 3. Then 1 plus 1 is 2. So we have 2 minus cos squared theta all upon cos squared theta is 3. Then we can split this to have 2 upon cos squared theta minus cos squared theta upon cos squared theta is 3. Then this cancels to give us 1, so we are having 2 into 1 upon cos squared theta minus 1 is equal to 3. When this 1 goes over, we have 2 into 1 upon cos squared theta is equal to, it will become plus 1 there, so 3 plus 1 is 4. Then I can divide both sides by 2, and then I have 1 upon cos squared theta is equal to 4 upon 2 is 2. Then I can take the roots of both sides, and the root will give me root of 1 is 1 upon root of this is cos theta is equal to root 2, right? So we are having that inverse of cos theta is root 2. So if I make the cos theta the subject by cross multiplying, I can have root 2 cos theta is 1, which implies that cos theta is equal to 1 upon root 2. Then what's the cos that gives me 1 upon root 2? Is a cos 45. Cos 45 is 1 upon root 2 or root 2 upon 2, as we remember. So what we have here is that theta is cos inverse of 1 upon root 2. And cos inverse of 1 upon root 2 is 45 degrees. That's theta is 45 degrees. So our answer is option B. Now, we'll take assignments now. Remember to subscribe to this channel so that you get notifications about our next classes. So subscribe, turn on the notification, then share the link, and then invite your friends also. Make your comments. If you have any issues, comment on the comment section, then share the link, subscribe, and then for our assignments, get UTME past question, the Jamb past question. You can get any of them. Then find the following questions: 2014 question 37, 2009 question 34, 1985 question 34, 1986 question 32, and the 2002 question 31. Let's just take these 5 assignments. Make sure you solve them before you view the next video. Please do not cheat. Try to solve these problems on your own and solve other problems. So if there is any question you encounter while solving, if there is anyone that you find difficult or tough, make sure you comment on the comment section so that we'll see them and we'll solve them together. But solve these ones. The next video will be correction to these problems. So make sure you solve them before you watch that next video. Physics classes are equally coming up. So make sure you turn on notifications because we start posting video tutorials on physics, both for UTME, WAEC, and the Jamb, and all of them, and nursing schools also. So make sure you turn the notification on. And then, if you have not gotten our physics textbook, it is very essential that you have a copy of it. It covers past questions and it's a textbook, but it has all the past questions solved there. So get yourself a copy. We deliver nationwide. Anywhere you want it, you get a copy of it. So please, in the next video, we are going to solve the problems. Thank you.